morning again, everybody. So I'm talking about Ankush, which is a big data cluster management tool. So I work for Impetus Technologies, and we are a thought leader in consulting services for big data and cloud, and working with customers for a few years in big data and cloud. We saw that there was an opportunity for a tool which could work across different clouds and different vendors as far as technologies like Hadoop or Cassandra or Oracle NoSQL are concerned. So, what are the main reasons for having a big data cluster management tool? So firstly, Hadoop is becoming one of the main fundamental technologies driving any big data technology or strategy. And one of the biggest challenges is that Hadoop is not the only sole solution for solving data problems. We also talk about other technologies like NoSQL technologies, Cassandra, HBase, MongoDB, and you virtually end up creating multiple management tools and multiple interfaces for the developers and operations team for controlling and managing these environments. So, and of course, Hadoop itself is a very volatile environment where you have multiple distributions ranging from Cloudera to Hortonworks to Apache open source as well. And how do you provide and enable enterprises to move into big data space much easier and faster? And once you start a journey, how do you make things easier for the developer world and the operations world? That's where the main fundamental of Ankush comes into picture, where we have provided support for multiple technologies in the big data space to be easily managed and configured using this simple UI-driven tool. We also provide support for cross-cloud deployments, which means you can choose and select between multiple cloud deployments. And one of the biggest value add that this tool can provide is development and QA teams usually require quick and dirty interfaces or environments for testing the developer builds. The easiest way of doing that is building such environments in the cloud, and that's where Ankush comes into picture, where it can enable you to create those environments in premises or in cloud as and when required on a single click. So overall, we're talking about reducing the time, the cost and efforts required for cluster setup. We do support in-premise and cloud clusters as well, and that means you can give your dev and the QA teams or even production teams the capability to quickly test out things or deploy their clusters as and when required. We also provide proactive monitoring and analytics, which is provided by most of the Hadoop distributions or most of the independent NoSQL solutions. But again, the challenge is how do you give the operations team a single window or interface rather than jumping into different tools altogether. So Ankush has been built to be technology and vendor neutral. So what are the key features? Currently we support Ankush for any kind of Hadoop distribution and Oracle NoSQL. We would be open sourcing the product the next month or so, and we'll be adding support for multiple other distributions in big data space ranging from Cassandra, Storm, MongoDB and other tools. And of course, also take care of one of the bigger challenges in Hadoop, which is version management. So you have, when you talk about Hadoop, you're not talking about just a single Hadoop component, we're talking about an entire space, and many other tools. So how do you manage everything again in a single click? And one of the other challenges that you would see is how do you move from one version to another seamlessly and provide certification between different kind of versions and different kind of components in the Hadoop ecosystem itself. Interestingly, we also have added support for something called flexible MapReduce, which would allow any of the cloud vendors out here to provide the same capability as Amazon EMR or Elastic MapReduce functionality, where clouds like Rackspace or GoGrid or any other cloud provider can use this tool to provide the same functionality, where you can have on-the-demand Elastic MapReduce functionality. I'll skip to the demo now and move back to here again, since the cloud deployment does take time. So I'll utilize the time properly. So what you see is a cluster overview tool right now, which is a kind of a dashboard, which allows you to look at your running clusters. So right now I have a Hadoop cluster which is deployed in cloud in AWS, while also I have Oracle NoSQL DB in premise. Developers can come in and deploy their own clusters as required in premise or in cloud. So here is the representation of the Oracle NoSQL store, which does of course have specifications or details of what is required from an Oracle data store. So you talk about shards and replication nodes in this Oracle NoSQL space, talking about different kind of relation graphs on what the machines are doing. Also talk about CPU and memory usage over here. So I'll quickly go and try creating a Hadoop cluster in the cloud, and as you see, I also get warnings in real time. So I'm getting a warning for one of my clusters that is running in the cloud, and says my CPU utilization has gone way above than the one that I've prescribed as a rule, and I can take some action to take care of it. So how do you quickly go and deploy a cluster? So I'm going to create a Hadoop cluster in the cloud. So I'll be giving a logical name for this, and I'll be talking about installing things in the cloud. Since I want to move things better and faster, what I'm going to use is a ready-made AMI rather than deploying something from scratch, which is also enabled over here. And I'm right now optimizing so that the AMI is used for picking up the packages that will be deployed. Of course, we can pick up things from the internet as well, from the Apache repository or from Cloudera repository or Hotmail repository as it is required. So here I'm providing Amazon EC2 as the service provider, and I'll be creating a 3-node cluster on this cloud. Hopefully the network should be okay for me to get the results really soon. Okay, I do have the results for my account. I'll be creating a 3-node cluster, and I'll be filling in the necessary requirements as far as key pairs or security groups are concerned, which anybody who has worked in a cloud environment would be aware of. We'll be using a medium instance of Hadoop of AWS EC2, and using a pre-configured AMI, which kind of reduces my overall uptime. So the basis of providing a machine images to reduce the overall time and also provide some kind of standardization as far as the cloud is concerned. I can also have something called auto terminate, which would allow me to run this creation of this cluster in a Elastic MapReduce way, where once I submit my jobs, cluster will be terminated and vanish, so that you don't have to pay extra for the job you are doing. So it actually uses the auto scalability and auto termination functionality of the cloud. I want to quickly provide some authentication details for my cloud account so that I can create a secure cluster in place. I'll be using Apache distribution today. I could also use Cloudera or others, and I can also select between different versions. Again, for the sake of using the AMI configured value rather than downloading things from the internet, I will be using and setting up the local paths. Let's say I want to configure Hive as a component, which is a SQL-like engine over Hadoop MapReduce, which allows any SQL developer to come in and use Hadoop as they would use in a traditional data warehouse environment. Also going to configure another component called Zookeeper, which is a backbone for many functionalities that are run in Hadoop. So again, I'm using a local path rather than trying to download things from the cloud. So once I do a deploy, what's going to happen in the background is I'm going to go and create the instances in the cloud, set up Hadoop cluster, set up the Hadoop ecosystem components, set up security and everything in place, and then enable an end-to-end functionality. I can have as many clouds here as many instances as possible. So by the time we will get the cluster ready, let me go browse through some of the functionalities that are available for an existing cluster. So I see that my name node, which is basically the master for Hadoop, is running on this IP address. I have 4 data nodes in this center. I have 2 ecosystem components, which is Hive and Pay. And I have a capacity of 8 maps and 8 reducers. I did have 2 complete jobs. I do have details of my usage of each node, so I can figure out whether the services are running fine on each or not, and what are the memory and CPU utilizations. I can of course go and submit a job in Hadoop. Let me run a Pi simulation, which is a part of standard Hadoop example. I can pass my arguments to the job from here itself. And hopefully I should see my details of my jobs over here in a second while it gets submitted. Of course I can go and do job monitoring from here as well, where I can look at the completed tasks, look at what are the tasks that were run earlier, and look at configurations. This is an important functionality in Hadoop, where I can go in and change the configuration for various parameters. From here I could go and deploy different components. I could look at changing the configuration of the Hadoop cluster itself, which itself is a tedious task if you're talking about a command line based interface, because you are talking about multiple files where you need to go into shell script and then changing everything from there. This tool allows you to change everything from a simple UI based interface, and thus actually add a lot of value add as far as developer performance is concerned in doing things faster. Of course, I do get a steady state of the cluster itself as a part of my statistics over here. So as you can see, my CPU usage and memory usage seem to be under limits. also see my running job right now. So this is the job that is being run. I can see that my maps have been running at 44% completeness. And the job has finished. So these are some of the capabilities. Of course, I can go and add more nodes over here, which is just as simple as providing more details of the node. I can run commands from here, such as archiving or disk copying or balancing. I can also manage jobs and view log files from here. Let's look at our cluster, which is still deploying. And meanwhile, I can go back to some of the features again back over here. Since the Amazon Web Cloud does take some time in overall getting up the machines ready. So what are the general use cases where you would be using Ankush? Of course, managing multiple clusters from one location, starting off with an open source Hadoop distribution like Apache Hadoop, and then going forward to the commercial distributions is also one of the possible use cases. Talking about different data technologies like Cassandra and MongoDB is another use case where essentially you are running multiple technologies, and the central tool can enable you to both configure, install, manage and monitor all the tools from a single place. Ankush also comes with pre-certified stacks, which means that we do some testing at our end to ensure that there is compatibility between different kind of distributions and different kind of versions, and serve as a test bed, which we see is a very powerful feature, allowing you to launch and scale on demand in cloud or in premise, whether it is bare metal or private cloud, and play around to figure out what are the best parameters for a given set of job or analytics that I'm trying to run on my Hadoop environment. So we would be open sourcing this tool for some of the components. You are welcome to look at www.impetus.com or bigdata.impetus.com website to see when we are open sourcing it, so that you can come in and use this tool, evaluate and use it in your environment. We would be adding support for Storm, Cassandra, Kafka, Elasticsearch, which is a search engine, MongoDB, and the different kind of Hadoop distribution ranging from CDH4, Apache, 2x, Autonomous HTTP, and multiple cloud support. So Rackspace, GoGrid, Terramark, all will be supported over here. So you can be reached on bigdata.impetus.com. We are in booth 120, and let's see if we have been lucky to get my cluster running. Yeah, it does. So it managed to have it running in under 10 minutes, I think. So this is our cluster that we just created. We have this as the name node over here. Here we have 3 data nodes configured over here, and we should also be getting the CPU and memory utilization from here. Any questions regarding this tool? Okay, feel free to meet us in booth 120 if you have any questions or concerns. We do of course have multiple other open source products as well as commercial products in the big data space, and we provide end-to-end services in big data ranging from architecture, design to strategy to implementation and QA testing. Thank you for your time today.